Welcome back to my today's session. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering in IARE College. Today I am going to discuss about the magnetostatics and the time varying field. So these are some important short questions which is very useful for your exam. So what is the first question? First question is, combine the electromagnetic forces to extract the Lorentz force equation. Combine the electromagnetic forces to extract the Lorentz force. We know when the force acquired by the point charge when they kept in the electrostatic field. If there is an electrostatic field and if we keep one unit charge there, it will feel some force, and this force is known as the we are getting from the Coulomb's law. This force we will get from the Coulomb's law. So what is this? This value is the force is equal to Q into E. Now the magnetic force, however, always again, as this is an electromagnetic field means electric field with superimposed magnetic field is there. So as this is an electromagnetic field, and if we keep one unit charge there, it will also feel some magnetic force. And as per our knowledge, the magnetic force always acts perpendicular to the velocity because it is only useful for the moving charge. So we can write that Fm is equal to Q V cross V. V is the velocity, and what is V? V is nothing but the magnetic flux density. So if what is the total force on this? The total force F is equal to Fe plus Fm. Fe is the electrostatic force. Fm is the force due to the movable charge in a magnetic field. So what is the total charge? Total charge is equal to QE plus Q V cross B. So what is the value? Q is equal to E plus V cross B, and this is known as the Lorentz force. This force is known as the Lorentz force. Now we are moving to our second question. What is the second question? Extract the expression for force between two straight long line and parallel current carrying conductor. Already we have discussed many times. Again, one more time, we have two long current carrying conductor A and B. IA current is flowing and IB current is flowing in the B conductor. We want to calculate the force on B due to A. Or we can also calculate force on A due to B. So first we are doing the force on B due to A. And what is the formula? The formula is the B from A, the magnetic field due to the A is into current IB into the distance between them. Now we have to calculate the BA from the Ampere circuital law. For Ampere circuital law, we know integration of HDL is equal to IA. So what is H? H integration of DL is equal to IA. So H is equal to, in a circular path means the DL is nothing but the 2 pi R. But here the R is equals to D. So 2 pi D into IA. So actually this is the L. L is the length of the conductor. So what is H? H is equal to IA by 2 pi D. What is B then? B is equal to mu H is equal to mu IA by 2 pi d. So what value we will write? Mu IA IB L by 2 pi d. So what is the force per unit length? Actually, as this is a long conductor, we cannot measure the length, actual length. So we can write FBA is equal by L. So it is mu IA IB by 2 pi d. We have taken capital current. So mu IA IB by 2 pi d. Next problem. Consider a solid sphere of radius 5 cm made of perfect electric conductor. If 1 million electrons are added to the space, the electrons will be distributed uniformly over the entire volume of the sphere, uniformly over the outer surface of the sphere, connected around the center of the sphere, and along the straight line of the sphere. This is a GATE question of 2017, and the answer is the electric field inside a perfect electric conductor is always 0, and there is a tendency of the charge is always stay outside of the, there is a general tendency of the charge is to stay outside of a sphere. So the charge will be stay in the outside. So answer B is the correct answer. Write the limitations of the moving charge in the magnetic field. The limitation of the moving charge, first of all, when the moving charge is going in the magnetic field, already we checked, force on this is equal to Q V cross B, and Q V B sin theta. So from this equation only we can tell the limitation. What are the limitations? If the velocity of the charge of the magnetic field is 0, the force experienced is also 0. If it is not a moving charge, it is a static charge, there will be no charge. If the velocity of the direction and the magnetic field direction are parallel to each other, if the direction of B and the direction of V are parallel to each other, then theta is equal to 0 degree and sine 0 is equal to 0. So if the velocity of the direction and magnetic field directions are parallel to each other, then the force experienced is 0. To say that moving charge in a magnetic field experience a force velocity must be, to get the maximum charge, the theta value must be 90 degree, and that case if M is equal to Q V B. Next questions we are going, deduce the force on current element, deduce the force on the current element due to the magnetic field. Let us consider a long conductor. We are conducting one long conductor with L, which is partitioned in the small part, and each part the current is flowing is the I current is flowing, and the length is dl. So we know that the df is equal to dq v cross b. What is the meaning of the velocity? Velocity means the displacement into time, the time taken to displace this dl distance of the charge. So we can write dl dt by d. This is the one equation. We can write it in the different way, but this is the first equation we can use here. So what is dq? dq is nothing but the, what is dq? dq is nothing but the rho v into dv, where rho v is the volume charge density. So already we got rho v is equal to volume charge density. So what is df? df is equal to, we can write dq dl by dt cross b. This is the one equation. We can also write rho v into dv v cross b. This is the another equation. Again we can write the equation like rho v into v in the rho v into V from the unit 2, we know this is equal to the current density J. This is also equals to the current density J. We can also prove this equation that the rho V into rho V dot V, rho V dot V. So what is the meaning of the V? Rho V. Rho V is equal to nothing but the Q by dV or dQ by dV into velocity. Velocity means dl by dt. So if we divide the, so dq by dt, what is the meaning of the dq? We can also rewrite it dq by dt into dl by dv. Here v is the volume. If the small v is equal to volume. So dq by dt is nothing but the current di, and what is the dl by dv? dl means the line and dv is the volume. So we are getting the ds because volume is equal to surface into the length. So di by ds, and di by ds is nothing but the j. So we are getting here rho v and v we combine together and we got the value of the j. So j cross b dv. Again, we can also write what is the value meaning of the j? J is equal to, we got di by ds, di by ds. So di by ds cross b into dv. So dv by ds is, again we can write it as the dl, same thing. So we can write I cross b is equal to dl. So if we want to remove the I cross b, we will get force is equal to bil sin theta. So this is the force on the current carrying conductor due to the magnetic field. Classify the magnetic potential. Magnetic potential is basically two types. One is called the scalar magnetic potential, another one is called the vector magnetic potential. So what is the magnetic potential? Magnetic potential is the property of the substances or phenomena that gives rise to the magnetic field. This is the property or the certain substances or phenomena this gives rise to the magnetic field. It is basically two types. One is called the scalar magnetic field, another one is called the vector magnetic field. What is the meaning of the scalar magnetic field? So scalar magnetic field psi is the quantity of the classical magnetism and analogous to the electrical potential. From the electrostatics, we know that the E is equal to delta V. So similarly, if we go for the magnetic field, we will get H is equal to minus delta Vm. And what is the Vm? Vm is the vector magnetic field, the vector or scalar magnetic field. What is the divergence of curl? What is the divergence? Grad cross A, and this value is always comes the 0. The divergence means grad cross A is equal to 0. How we can prove this? Say A is a vector is equal to x, ax plus y, ay. I am taking a simple xy plane. You can do it for the z plane also. So what is the value of the grad cross A? What is the meaning of grad cross? Del by del x ax plus del by del y ay. So this is the grad. So how to write the grad cross A? So we can write it in a vector format ax and ay. What is the meaning of the grad? First line del by del x, del by del y, x, y. So what we are getting here? Cross multiplication AX, or we can write like this. Del y by del x, del y by del x, AX minus del y by del x by del x by del y, AY. So we got this equation. Now if we want to do the grad means the grad dot x means, again, what is the meaning of grad dot a? Grad dot means grad cross a means del by del x by del y by del x, AX dot AX and again AY. So it is a cross multiplication, and cross multiplication value will always comes at the 0. So del cross del y we got. What is this? So it will come del by del x plus del AX by del y, AY, into del y by del x, AX, plus minus del x by del y, AY. So in the dot product, similar terms we can write, dissimilar terms will be the 0. So we are getting del square y del x squared AX minus AY 0 and del square x by del y square is equal to 0. So y is a constant with respect to x, so y is a constant with respect to x, so both will becomes at 0. So what is the vector magnetic potential? The magnetic potential A is the vector quantity of the classical magnetism defined so that the curl is equals to the grad cross A is equal to B. Already we know grad dot B is equal to 0 from the Gauss law, or we can tell it the Maxwell's second law. As we discussed earlier, grad dot grad cross A is equal to always 0. So B is equal to, we can write grad cross A into mu H. Grad cross A into mu H is equal to again grad cross A. So what is grad cross mu H is equal to grad cross A. So what is H? H is equal to grad cross A by mu. This is not required. Mu H is equal to grad cross A. So H is equal to grad cross A by mu. So applying curl both side, we got grad square H is equal to grad cross A by mu is equal to J. And after solving this, we will get grad square A is equal to mu J. And if we integrate the both side, A will be the integration of mu I dl. The detailed derivation we can find in my old lectures. Give the expression for the self-inductance solenoid. So let there is a solenoid as shown in the figure, and the N is the number of turns and capital N is the total number of turns. So magnetic field intensity inside the solenoid is V is equal to mu naught N into I, because the unit of H is equal to ampere turn per meter. So that's why we are taking the N, because N is equal to number of turns per unit. So what is the flux? Flux is equal to phi NBA. So mu into N is equal to N into L I A. So mu square Ni by AL. So what is the inductance? Inductance is equal to L into phi I. So if we put the value, we will get mu N square A by L. Give the expression for the magnetic flux in N turns if B and A are known. Let us consider a solenoid as shown in the figure. N is equal to number of turns per unit length and capital N is equal to total number of turns. So the flux will be the phi is equal to NBA. Define the magnetic dipole. Magnetic dipole is formed when two opposite magnetic charges are separated by a distance L, and the magnetic charge can be worked between the two lines plus qm and minus qm. In other words, a bar magnet with pole strength Qn and the distance between and the current I is flowing, M is equal to Qm into I. Define magnetization. If there exists a conductor consisting of the number of dipole in its volume, the magnet per unit volume is called as the magnetization. Magnetization M is equal to small m by V. M is equal to Qm into L and by A by L. So Qm by A. Write the expression for the torque due to moving charge. The expression of the torque due to moving charge T into B. So what is T? T is equal to 2 into torque on each side. So if there is one diagram, so torque in each side. So 2 into 4, what is the torque? 2 into force into distance from the axis of the rotation. So 2 into A by D by 2, and if we put the value, we will get, we know force is equal to VIL cos beta or sin theta by 2. Define the electric field intensity. Electric field intensity at a point is the force experienced by a unit positive charge placed at the point. And electric field intensity is a vector field and we sign it by E. Units of electrical potential per unit in SI units are volt per meter. The induced voltage in the coil is given by, already we have solved, E is equal to L di by dt. Find the H ampere per for a circular coil of diameter 1 meter and the carrying of a current of 2 ampere. So what is the H? H is equal to Ni by 2 R at the center. At the center the value is Ni by 2 R. Here number of turns is not mentioned, so we are taking as 1. So I by 2 R. What is the value of the I? I is the 2 ampere by 2 into diameter is 1 meter means R is half. Half means it will come the 4 value, it is the 2. Define the magnetic flux density. Magnetic flux density or displacement density can be defined as the magnetic flux per unit area. It is written by B. B is equal to flux per unit area ampere. So the unit is Weber per meter square and we can write it in one word, it is Tesla. And we got the relation also, B is equal to mu H, where mu is the permeability of the medium. And what is H? H is the, what is H? H is the field intensity in ampere turn per meter. What is the Stokes theorem? The Stokes theorem states that the surface integral of a curl of a function over a closed path or over a surface bounded by a closed path is equals to the line integral of the particular function around the surface. So we can write grad cross A ds. The Stokes theorem states that the surface integral of any function A dot ds is equal to grad cross A of dv. The function is equals to the volume integral of the divergence of the same or curl of the same. What is the Maxwell's third equation? Maxwell's third equation tells that grad cross H is equal to J. So if we want to modify it, we get it from the Ampere. We can prove it from the Ampere circuital law. The details derivation is already in my old lectures. You can find the details of this. And the modified Maxwell's third equation is the modified equation is the grad cross H is equal to J by d into dt, where d by d is nothing but the displacement current density. What is J? J is the current or conduction current density. We can write the Maxwell's third equation in the free space. In the free space, as there is no current, no conductor, so conduction current is 0, and we can write grad cross H is equal to d by d into dt. So these are the three variety of the Maxwell's third equation. Write the expression for energy stored in the capacitor and inductor. By the definition of the capacitance between the plate is, we can write that C is equal to Q by V for the electric potential, and dW is equal to Q by C into, and if we integrate these two, we will get W is equal to half CV square. Similarly, for the integrator also, for the inductor also, the energy is equal to half Li square. Energy of the inductor, energy in the capacitor is the half CV square. The both details is also available in my previous lectures. So thank you. Today I have discussed about some short questions in my these sessions, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.